6 is the last section for Unit 5 for systems. It's another applied section, so we're going through applied problems and setting them up and solving the system. So again, we're going through these. The first thing you want to be able to do is pick out your variables and what are we trying to figure out. So cashew nuts costing $22 a kilogram. In Brazil, nuts costing $6 a kilogram. The mixture weighs 50 kilograms and sells for 18 kilograms. How many kilograms of each type of nut were used in the mixture? So we're going to, you can use whatever we want. We can do cashew is C if you want, Brazilian's B, or you can go X and Y, it doesn't matter. Do you want to do C and B, or you want me to make them X and Y's? X and Y. Let's vote. X and Y, raise your hand. All right, X and Y. C and B?
Yeah, everyone with their hands up.
All right, sorry. C is X, Brazilian's Y. So it says cashew nuts costing 22 kilograms are mixed with Brazil nuts costing $16 a kilogram. The mixture weighs 50 kilograms. So the mixture that we don't know, that's what we want to steal. We don't know what the mixture of them is, but we know it's going to weigh this much. Okay. Okay. And then we know that we have 22x for cashews plus 16y equals what? What's that? Good. The important part I wanted you to get is a lot of people just put 18 there. That doesn't really make sense, right? We know how much they have, and we know how much it costs per kilogram. So we know the price of the bag. So we're going to put the whole price of the bag. Remember yesterday where we were given a of the stocks, how much it made? Okay, this is very similar. It tells you how much the bag costs. You just have to do a little bit of work to figure out the actual cost. So 18 times 50, like Luke said. So we're going to make that 900 here. And now we have our system. Okay, Maddie, what do you want to do? Substitution or elimination? Substitution. You have a variable you want to isolate? Sure, the y. Okay, so we're going to isolate the y. So Maddie got us to here. This is what we're going to substitute. Negative x plus 50. I'm going to put that right in for y right here. That's the substitution step, right? Okay, so here it is. 22x plus 16 times, like that. And then I'll put the equals 900. Did I lose anybody yet? Are we still staying with me? You do not have to do the same ways. You could do elimination if you want. You could isolate the y or the x if you'd like. Yeah, all that works. Okay. We're good? Distribute. 22x minus 16x. 16 times 50, I believe, is 800. Minus 800, and then we'll combine the x's. You guys are Math 10 now. You can do two algebra steps at once. 6x equals 100. Then we divide by 6. So x equals 50 over 3. Or you can write it as a decimal, which is, what is that? 16.6 repeating. Okay. So what does that represent? The amount of cashews. Good job. So there's 16.6 pounds of cashews. Or, yeah, kilograms, sorry. American influence. 16.6 kilograms of cashews. Yeah, and so we have to just go up here. We can plug in right here, 16.6. Now, this is where you got to be careful with decimals. If you do decimals around, you'll be slightly off with x. You want to use 16 and 2/3. Okay? You want to do x. Oh, no, we know x. Excuse me. Oh, that's not the button I want to hit. Sorry. It's not okay. 16 and 2/3. Hopefully you had your notes filled out. No, well, the picture's stored. I can go get the picture if I want, but it's okay. 16 2/3 plus y equals the 50 kilograms. That's all we're just checking. We're getting in the y right now. Yeah, so you don't want to write 0.6 repeating because you want an exact value. Okay, so we want to keep it in 2/3 so we can get exact. What's that? You can use the 50 over 3 as well, yeah. So what we're doing is we're going to minus this to figure out what y is. And so what you should have to figure out is 50 minus 16 and then take away another 2/3. So y is going to be 34, 33, and 1/3. So don't be panicked here. It's because these two things added up equal 50, which they need to be. Because look, 1/3 plus 2/3 is 1. 33 plus 16 is 49. 1 plus 49 is your 50. That's how you can write it exact. If you rounded, you would have said that this was 33.7 and this is 16.3, which isn't right. Okay, or no, you would have said 16.7, you would have said 33.3. Okay, which isn't exactly right. Okay? It's the idea of exact value. We have to be careful with that. Okay, so we pretty much just checked it. I already checked it because I just added those up with you guys and we got 50. Okay, you also can plug it back into this equation we had here. 22x plus the 16y. You can also put it in there and it should still work out. Okay? What's that? You confused now, Luke? Any other questions on this one before we go on to the next one? Only got 4 examples, doing distance, speed, and time on the back. Is it reduced? Yeah, so 50, you can use improper, is fine. So if you use 50 over 3 for this one, then this one you would have got 100 over 3. Yeah. We good? All right. Now I meant to push that time, sorry. Okay, example 2. So Earl, the chemist, has to make 180 milliliters of 60% hydrochloric acid solution. He has available 1 liter bottle of 45% and 1 liter bottle of 70% by volume. How many milliliters of each solution are mixed to make 60% of the hydrochloric acid solution? Good question. I don't want to know really. We're just gonna help him commit a crime, I think. Okay. So we need to work on like how do we set this up? Like what do we? I know it's a lot going on there. I know you're probably psyched out because it's actual chem in here. Okay. Yeah. You can make them into, well, it's percentages, so we don't want to do fractions. We're actually going to change them to what? Decimals, right? So like we're going to use, no, that's good. We're going to use 0.45, we're going to use 0.60, 0.70, and it looks like another 0.60 is somewhere. Like those are numbers that we should be thinking about for our percentages. Okay, how do we want to set them up though? Yeah, so we know we have, so first of all, we know that he has to make 180 milliliters. So that's like the last problem where we know that we have 50 kilograms of nuts. Okay, so 180 milliliters is going to be our total for the easy one. So it's going to be this. We need to figure out what this is. What's our x and our y's? What's x and y represent? Right. X is the 45%, good. And y is the what? 70%, good. How'd you guys get that? Yes? So it says he has available 1 liter bottle of 45% and 1 liter 70%. So that's what he has available, his options to make this. So if you're wondering, well, why didn't you use a 60%? Well, he wants to make a 60% out of those two. Do we see the problem now a little bit clearer? Worried about the chemistry part? No? Okay. Say it again.
Why is it only x plus y?
Well, because it's how much of each solution will give him the total. And we're going to figure out the mixture, what the mixture needs to be at the next one.
It's 180 per milliliters.
Yeah, he wants to make 180.
Oh, milliliters.
Right, he wants to make 180 milliliters. So our next one, so remember the last one, we had the one where Luke times 50 times the price per bag or whatever, or per nut. It was, what was it? It was 40, it was 50 times 18. 50 times 18. Same type of thing's going to happen here. We're going to take our solution sets. So we're going to take 0.45x plus 0.70y equals, what do we want? 60% of what? 180. All right, so let's walk through this one more time. I know there's a lot going on. Percentages were switched to decimals. That's why I wrote these here. We know that we're going to mix our two solutions. We don't know how we're going to mix them, how much of it, but we know that we're going to make 180 milliliters. So understand this, the x, this doesn't mean it's equal to 45%. It's probably wrong to write that. It means how much of it. Okay, so x represents how much of the 45%, y represents how much of the 70%. Okay, so again, I think substitution is probably the easiest here, especially with decimals. So I'm going to minus the x again. So y equals 180 minus the x. We're subbing that in right there. Okay, 0.45x plus 0.70 times 180 minus x. Can somebody get me what's 0.7 of 180? 36, 54, so it'd be like 126, I think. Okay. It is 126?
Yeah.
Okay. Can you do this one for me too? I think it's going to be 108. Okay, so that's where we're at. Is that right? Is it 108? Oh, I forgot something. It's 0.45x plus 0.7, nope, plus the 126 minus 0.7x. That's what I'm missing. Okay. Now we're solving for x, so we'll combine the x's and minus the 126 over. 0.45 minus 0.7 is 0.25 negative, equals a negative 18. And then we divide. We should get 72, I think. So x is 72 milliliters. Now this makes sense because x, okay, well it kind of could make sense. X is a smaller, so the 70% is too high, right? It has too much of it. So we're going to need some more of the smaller kind to kind of cancel that out or to bring it down a little bit. Okay? Does that make sense? Stay with me, Raj. Okay? So this right here, we'll put x in right there. 72 plus y equals 180 minus the 72. Y is 108. There's your two answers of how much you need of each. Okay, you can plug those in and check if you'd like. For the sake of time, we'll keep going. No, x is 72 milliliters. Sorry, that point's not there. Good question. Just 72 liters. Okay. Remember, that's how much of each type. Yeah? The 0.25. This right here? Good. This and this combined. So they're like terms. So 0.45 minus 0.70 is negative 0.25. Yep. That's a small thing I'm talking about. Good work. Thanks, Spencer. Anything else? Yep, Wally? You have something? You good? Okay, on to the back. Last page here. Okay, so I want everybody to make these two of these real quick. I'll pause the video, but make these two charts. Make a chart. All right, a little bit off. That's okay. Okay, so let's make a chart like that. So like this is where we're gonna put the like topic. So just gotta write topic here, and we're gonna be comparing two things. We'll figure that out in a second. And then here is distance, speed, time. The distance, speed, time chart. We use these in Math 20 as well. What's that? Topic. So like it's going to be what we're comparing. There's two things we're comparing. Okay, I'll let you write that down. Like I'll pause the video, but make this box for both problems right now, so we're ready to go. Okay, let's talk about how to set these up. Okay, well, you'll have one of these on the test. I'll make sure of it. Okay.
No.
Oh yeah. Okay, so a student drove the 1245 kilometer from Edmonton to Vancouver in 16.5 hours. This included a 1 hour stop in Golden and a 30-minute stop in Kamloops. She averaged 100 kilometers an hour on the divided highway and 75 kilometers on the non-divided. How much time was she spent on each of the highways? So what are the two things we're comparing? Divided, non-divided. So you're going to say highway and then like mountain roads or whatever. Okay. We're comparing highway and mountain roads. So we know that her distance, okay, yeah, distance is 1245, but what we're going to do is we're going to go ahead and let's go for speed first. How fast was she going? 100K. And then she was going 75. How much time did she spend on the divided highways? So that's what we're trying to figure out. That's like our variables. But how would we express that in distance? Close. It's because we're doing distance though. So this is a very good point. He said time over speed, but if distance equals excuse me, not distance. If time equals distance over speed, then what does distance equal?
Distance equals
Time times speed. Good job, Hannah. Time times speed. So what is time times speed? 100x. 75y. Okay. This here. Time equals distance over speed. And then what I said was, how do you get distance by itself? You time the s over. So time times speed equals distance, and that's how we got these two for distance. What's that? Shh. What's up, Joseph? Which one's which? So this one here is highway. This one's mountain road, so slower, faster. Does that make sense? So this would be non-divided, divided, right? Or no, this is opposite. Divided, non-divided. You go faster on divided. Yeah. Okay. All right, so how can we set up a system of equations to solve this problem? Say it one more time.
100x plus 75y
100x plus 75y.
equals 1,245.
How'd you get 1,245?
It's the total distance.
Good. Okay, so guys, he got the first one down. Just one sec, Lola. I'll let you try the second one. So what he just got, he got the distance equation. Distance equation is 100x plus 75y equals the total distance traveled. Total distance traveled, they told you right here. Does that make sense? What's the other one we're going to compare it to? Logan, did you know what you're going to compare it to? No?
What's the last
Time. Correct. What's that?
What's the last number?
1245.
How did you get that though?
Right here. That's how far they travel. No, these are all good questions. Okay, so this is the distance. You want to put a d by it, but this is the distance equation. And yeah, Luke's right. We want to do time. What's the time equation? X plus y equals. Okay, so it's a little tricky because we have to account for the time that he was stopped. So we have to subtract 1.5 to 16 and a half. Right? Because he stopped for an hour and a half. Correct? So that's going to be what? 15? So 15 hours. X plus y should equal 15. You have your two equations. I'm going to pause. I want you guys to try to solve for x and y, please. Come on. Okay, so this one here. So you guys did a pretty good job. I'll use substitution. I saw law of elimination. Elimination's great. You could times everything by 100 if you want and subtract the x's. Make sure everything gets hit with 100, though. That's the common mistake I saw. But I'll just use elimination because it just seems to be a little bit easier in my mind. So y equals negative x plus 15. I take that. I put it there for the y. So here we go. 100x plus 75 times negative x plus 15 equals 1245. Ah. Okay, so then we have to distribute. So 100x minus 75x. Okay, 75 times 15. Somebody do that? What's that? Thank you. Okay, 100 minus 75 is 25. We'll subtract this over. One too many ones. That gives me 120. Okay, and what do you get? 4.8. Okay, so x equals 4.8, so that means 4.8 hours she spent on the divided highway. So that means the most for driving then was on the mountain roads. Okay. All right, let's get this one set up. Last one. Shh, stop the side chatter, please. Stop the side chatter. Let's get this done, please. Okay, that's side chatter, Ridge. Okay, make your distance. You already did that. Actually, you should have already. All right. Okay, so our topic. So we got a small cruise boat took 3 hours to travel 36 kilometers down a river with current. On the return trip, 4 hours. Trip took 4 hours against the current. Find the speed of the current and the speed of the small cruise boat in still water. Okay, so we have downstream versus upstream is what we're comparing. Okay, our x and y is going to be the answer for their speeds. So we're thinking in terms of, we have, let's see here, do our distance, speed, and time. So we know the time that it took to go downstream was what?
3 hours.
Okay, so we put a 3. And we know the time it took to go upstream for 4 hours. Okay. Close. It's close. Okay, so I'll help you this. X is going to equal kilometers an hour of the boat. Y is going to be kilometers an hour of the stream. Of the current. That's what your X and Y are. What's that? Okay, so X is kilometers an hour of the boat. Y is kilometer an hour of the current. Okay, so in terms of speed, how would you express the speed then? So I'm going downstream. Exactly. I'm combining the boat speed with the current speed because you're going together. So this downstream is X plus Y. Upstream, X minus Y. Because it's your boat against the stream now.
This one is kind of hard.
Yeah.
Like, how did you know that? It's
Oh, but it makes sense though, right?
But where does it say that that's the speed of the boat? Because it's common knowledge.
Well, you mean to find the variables?
Yeah.
Like X and Y? Because it says find this. It says find the speed of the boat and the current in still water, so that's my X and Y. It's telling me my X and Y what I'm trying to find. Okay. Distance. How do we express distance? What's distance you said earlier, Hannah? It's what? Speed times time, right? So it's just these times each other. These times each other. Okay, hold on, one question at a time. What? Yep. Yep. So we'll set these equal to 36. That'll help our speed. That'll be our part of our equation. Okay, so you just figured out that it, like Josephine said, isn't just 36. Yeah, it is 36, but we need to figure out, we're going to use that to our advantage. 3x plus 3y is 36, right? We'll just use this one. You could use either. 3x plus 3y is 36. They're going 36 both directions. Okay, so you could have done it for upstream if you'd like. Okay. Matter of fact, that's going to be our other one. So those are our two systems. Which one does it look like you might want to use here? Do you see anything to substitute? I wouldn't use substitution. I use elimination for sure because there's no variables by themselves. Okay, so I would times this by 4, this by 3. So I would get 12x minus 12y, or plus 12y, equals 120, 144. 90, 108. Okay, now you kind of see a weird thing. We can add or subtract. If I subtract, these will cancel, the 12x's. If I add, the 12y's will cancel.
Just add. I like that.
Okay, we'll add. So that means 24x. Eliminate. That's going to be 252. And we divide. X is 10.5. So that stands for the speed downstream was 10.5 kilometers an hour. Yeah, so we can plug it in and find the y. Find the speed. Yeah, wants both of them, so we need to find y as well. So how can we do that? either of these. It's fine. So let's put it right here. The current's obviously going to be a lot slower, because if the current was a lot faster than your boat, it'd take forever to go anywhere. Okay?
Unless you're going downstream.
But that, yeah, unless you're going downstream. 30. Thanks, Rich. 31.5 will subtract to 36 now. So 3y equals 4.5. So it's really slow. It's 1 point something. What is it? 1 point, what is it? 1.5? Okay. So y is 1.5. Ah. .5 kilometers an hour. Good. Okay, we're done with that.